The Boeing 747 dominated aviation for over 5 decades. Nothing seemed capable of replacing its iconic presence. Then, Boeing built something that challenges everything we knew about size and capacity. Here is whether the 777X actually surpasses the legendary Boeing 747 and what the numbers reveal. The Boeing 747 changed aviation forever. When it first flew in 1969, nothing came close to its size, capacity, or presence on the tarmac. Generations of passengers remember the experience of boarding a double-deck widebody for the first time. Now Boeing claims the 777X takes over that role. The larger 777-9 variant is positioned as the natural successor for airlines retiring aging Boeing 747 fleets. But does the 777X actually surpass the legendary Boeing 747 in size? The answer involves dimensions, passenger capacity, and engineering philosophy that reveals something fascinating about both aircraft. Start with what the 777X promises. The aircraft delivers the largest engines ever to enter commercial service. It achieves the highest passenger capacity of any twin-engine jet ever built. It improves efficiency over the already highly regarded original 777 family. The 777 family itself has been the best-selling wide-body aircraft in aviation history. Launched in 1994, it moved through several variants, establishing a dominance that no competitor successfully challenged. The 777X continues this story while introducing new generation technology. The improvements are substantial. New composite wing design with revolutionary folding wingtips. GE9X engines providing exceptional thrust and fuel efficiency. Updated cabin systems improving passenger comfort across long-haul operations. However, the 777X maintains the same basic design philosophy and metal fuselage construction as the original 777. Internal fuselage space increases slightly through thinner walls and more efficient insulation. But the fundamental architecture reflects evolution rather than revolution. This design continuity matters. Airlines transitioning from 777 operations to 777X operations benefit from accumulated expertise. Maintenance teams know the fundamentals. Operational procedures transfer logically. The learning curve is manageable. Now, examine the passenger capacity comparison directly. Two passenger versions of the 777X exist, the larger 777-9 and the smaller 777-8. Each serves different airline requirements. The 777-9, the first variant entering service targeting early 2027, offers capacity of approximately 426 passengers in a two-class configuration. This number sits comfortably alongside the Boeing 747's typical operational capacity. The newer and largest Boeing 747 variant, the Boeing 747-8, carries a typical capacity of 410 passengers across 3 classes. The Boeing 747-8's maximum rated capacity reaches 563 passengers in a high-density single-class configuration, though no airline operates at these extreme densities. Lufthansa operates the Boeing 747-8 in a 4-class configuration with 364 seats. Korean Air and Air China seat slightly more passengers on their Boeing 747 operations. Configuration choices ultimately determine effective capacity more than maximum specifications. The 777-9's 426-seat 2-class capacity positions it clearly alongside the Boeing 747 for typical airline operations. Airlines considering the 777X as a Boeing 747 replacement will find the capacity transition manageable. The smaller 777-8 seats approximately 384 passengers. This places it in direct competition with the A350-1000 for airlines needing high-capacity widebodies without reaching the largest possible aircraft size. Now examine the physical dimensions where the comparison becomes particularly interesting. The 777-9 measures 251 feet and 9 inches in total length, or 76.72 meters. This makes the 777-9 the longest commercial aircraft ever built, a record that places Boeing's newest widebody in exclusive company. The Boeing 747-8 measures 250 feet and 2 inches in total length, or 76.3 meters. The difference is less than 2 feet. Remarkably close for two aircraft separated by decades of development. The 777-9 is marginally longer than the Boeing 747-8, but the difference is almost negligible in practical terms. Both aircraft occupy comparable space in physical length along airport infrastructure. Wingspan comparison introduces the most dramatic dimensional difference between these aircraft. The 777X's wing design is revolutionary. When extended during flight, the wingspan reaches 235 feet and 5 inches or 71.75 meters. This massive wingspan provides significant aerodynamic efficiency benefits. Extended wings create more lift per unit of fuel burned. The aerodynamic advantages translate directly to operating cost improvements on every flight. The Boeing 747 extends even further with its wingspan reaching 261 feet and 8 inches or 79.75 meters. This genuinely enormous wingspan gave the Boeing 747 significant operational limitations throughout its service life. The Boeing 747's wingspan placed it in the highest airport compatibility rating category. It can only operate at specific airports with gates having sufficient spacing to accommodate the Super Jumbo's width. This restriction limited the Boeing 747's network flexibility throughout its career. The A380 faces identical restrictions. Its enormous dimensions confine it to the world's largest hub airports. Secondary airports and smaller international destinations remain inaccessible regardless of demand. Boeing solved this problem with the 777X through engineering innovation. The folding wingtips reduced the 777X's on-ground wingspan to just 212 feet and 8 inches or 64.8 meters. This places the aircraft in a standard airport compatibility category. The folding mechanism works automatically after landing. The massive wingtips fold upward, reducing the effective wingspan for ground operations. The 777X can park at the same gates used by smaller wide-body aircraft. This distinction is commercially significant. The 777X delivers Boeing 747 level capacity without Boeing 747 level airport restrictions. Airlines can deploy the 777X to destinations that could never accommodate a Boeing 747 or a 380. Route network planning becomes more flexible. Secondary international airports become viable destinations for 777X operations. Airlines gain capacity on more routes than the Boeing 747 ever allowed. The wingspan engineering also uses lighter carbon fiber composite materials rather than traditional aluminum construction. This weight reduction contributes directly to the efficiency improvements Boeing promises. Combined with the higher bypass ratio of the GE9X engines and the increased lift from extended wings during flight, the 777X delivers significant efficiency improvements over both the Boeing 747 and original 777 variants. Compare these weight efficiency characteristics against the A380. Airbus's Super Jumbo retains the title for largest commercial aircraft by passenger capacity, volume, and weight. The A380 can carry more passengers than either the 777-9 or Boeing 747-8. But the A380 measures approximately 238 feet and 7 inches, or 72.72 meters in length. This makes the A380 actually 4 meters shorter than the 777-9, despite its greater passenger capacity. The double-deck configuration achieves density through vertical space rather than fuselage length. The A380's enormous wingspan of nearly 80 meters creates the same airport compatibility problems as the largest Boeing 747 variants. The Super Jumbo is confined to major hub operations. Its commercial case depends on maximizing passengers between the highest traffic city pairs. The 777X positions itself differently. It delivers capacity close to the A380 and Boeing 747 without their airport limitations. It provides flexibility that neither competitor can match. For airlines currently operating Boeing 747 fleets, the 777-9 represents the logical successor. Airlines retiring Boeing 747-400s and Boeing 747-8s need aircraft providing comparable capacity on their highest demand long-haul routes. The 777-9 serves this requirement effectively. Its capacity matches typical Boeing 747 operational configurations. Its range enables the same long-haul routes. Its twin-engine configuration provides better economics, and its airport compatibility opens network opportunities the Boeing 747 could never access. As of May 2026, the 777X program is advancing towards certification and early 2027 deliveries. Lufthansa's first passenger-configured 777-9 completed its maiden flight in May 2026. The aircraft is progressing through final certification requirements. So, is the 777X bigger than the Boeing 747? The answer depends entirely on which dimension matters. In total length, the 777-9 surpasses the Boeing 747-8, making it the longest commercial aircraft ever built. In wingspan, the Boeing 747 extends further than the 777X during flight. In maximum passenger capacity, the Boeing 747's extreme density configurations exceed the 777X's typical operating ranges. But in practical operational terms, the 777-9 matches the Boeing 747-8I's typical passenger capacity while exceeding it in length and matching it in operational range. The 777X is not dramatically bigger than the Boeing 747. It is precisely the right size to replace it. The 777X takes everything the Boeing 747 represented in commercial aviation and delivers it more efficiently, more flexibly, and with fewer operational restrictions. That is why the 777-9 is positioned as the Boeing 747's natural successor for the next generation of long-haul aviation. The legendary jumbo jet is retiring across airline fleets. The 777X is ready to take its place, not by being dramatically larger, but by being more capable where it matters most.